Alright guys, Mike, I'm back again. I'm going to show you guys what I actually do in my shop. Here I have a AR-15 barrel that a friend of mine gave me. It is under 16 inches, which is illegal in the state of California to put on a rifle. So he asked me if I could weld on this muzzle device so that it would be the full 16 inches. So before I do any of that, I want to check to make sure that it is going to give it the full 16 inches. So I've got a bolt here. The shop that he bought it from said that that muzzle device would make that barrel 16 inches. But anything I work on, I want to make sure that it's going to be completely legal. So according to the state of California, to get the 16 inches, you go from the bolt face. So I've got a rod here with a piece of electrical tape on it so that I can stick it down into the barrel and touch the bolt face and see exactly how long this is going to be. So very carefully slide this in, put pressure on the bolt face to keep it up against the edge, and it is very close. It should be okay, but it's right on the border of being legal. So I might make a little spacer to put in there just to make sure that it pushes it past that little edge there. And double check my measurements on the rod here, make sure that tape is at 16, and the tape is, well, it's a 1/16 of an inch shorter, so definitely have to have some kind of a spacer to make it legal. So that'll be my next segment here. I don't know if it's going to be on this video, but it will be coming out very shortly to make sure that this is all legal. So we'll get to that when we can. Alright, so here's the part that I'm going to be working on. Customer purchased this in another state, brought it back here to California, wants to build a rifle out of it. In California you could build an AR pistol and it would be legal, but not an AR rifle because the barrel is under 16 inches. Right now it is about 13 and a half. In California you can weld on a muzzle device, just pin it and weld it in to meet the overall length. So he gave this to me and asked me if I could do it. I told him yeah, but first I wanted to measure it to make sure that it was going to actually be legal still. So I have a cleaning rod here that I've laid out a mark. I don't know how well you guys are going to be able to see this, but there's a little white dot right at the 16-inch mark. And the bottom edge of that dot is right dead on at 16 inches. So the measurement, according to ATF, of barrel length is the bolt face. So I have a bolt face from another rifle here. And I'll carefully insert this so I don't touch any of the, mess up any of the threads here. And we are short. This is why you always want to double check, even though a shop tells you it's good, you always want to double check to make sure it is good, because that's an 1/8 of an inch difference, and that 1/8 of an inch is the difference between being legal and this being a felony. I already told the customer, he asked me if I could put a spacer in, which I do have precision machined washers that I could use, but you can see it only leaves Sorry, my phone's blowing up. A couple threads sticking out. It's about 7 threads, which would be fine, except for the makers of this muzzle device recess in well over 1/8 of an inch before they start their threads. So it would only be touching on the very tip 4 threads, and that might be fine for some people, but I won't let anything go out of my shop that I feel is unsafe. So I told the customer, he said that's fine because he knows that I make muzzle brakes and muzzle devices myself, so he asked me if I could machine something up. So that's what I'm going to do. Now, I need to get my length. I make standardized sizes. So right now this is at 2 7/8. We'll make it good. So I'll machine one and I'll do it at 3. That'll make sure that it's got more than enough room. Make sure that it's legal. So that'll be the next video. Might be the next segment of this video, depending on if I can get my machine set up in time or not. So I'm going to try to get this video out in a couple days and show you guys what I actually do on my milling machine and lathe. Alright, this is what we're working with here. These are the blanks that I machine up. I've got a bunch of them sitting here, and our length is 2 7/8, which will give us, with the crush washer, the overall 3 inches. So I'm going to come up and just do a quick little facing cut here, just to make sure it's all true. Touch off, going the wrong way, and a little bit too fast, so drop my speed down here. There we go. Just ignore that. It probably could cut a little faster than that, but that surface is squared off now, so I can get my drill set up for the threaded hole. Tailstock in here. I'm using a number 4 starter drill here, or centering drill. Start. Let me get my other drill bits over here So for the threaded hole, depending on what charts and calculations you use, it needs to be a 29/64 drill bit, and that's under, but like most drill bits, when you cut it, there's a little bit of variation there, so it'll be slightly over whatever your drill bit is. On this hole, this is the side I'll thread. I'll go in about 1.5 inches before I stop, because I'll end up flipping it around and going in on the other side with a much bigger diameter. Bits out here. Sorry, I know I'm blocking the camera a little bit. Somewhat difficult for me to do this. I haven't done a whole lot of filming out here, so still kind of getting the hang of this. I've got the part turned around and reset here. I'm going to start with the centering drill. Nice centered hole. Now these drill bits that I'm using are both of these are cobalt bits because I make quite a few of these and I got tired of having to resharpen my bits all the time, and I can cut a little bit faster with the cobalt and it cuts a little bit slower. Finger destroyers. Alright, all the lathe work is done for the time being. I've got the milling cutting bit here touched off. I'm just going to take a quick measurement to figure out what the depth of cut needs to be. I'm just going to use my calipers because this isn't got to be real super crazy accurate. Alright, I'm at 0.8620 and I need to go down to 0.75, which is the standard AR-15 wrench attachment on the armorer's wrench. So 0.8625 minus 0.75 divided by 2, 56 thousandths on each side. So we'll start it up, I'll get some lube on there, and we'll start making our cuts until we get the depth we need, and then flip it over and start on the other side. Alright, and we're ready to machine. You'll notice almost always I'm using this tapping fluid. Doesn't take a whole lot, and it machines really well. My depth of cut here only needs to be 56 thousandths on each side. That's 50. I'm going to take it to 53, and then I'll do a finishing cut on each side on the end here. So I'll drop my table back down, bring it back to 0 here. Rotate this around 180 degrees. Lock it, clear off my chips here. That is close, and I always measure to make sure so that is barely fitting on there. The paint finish that I use, the Duracup paint, adds a couple thousandths, so I'm going to go just a couple, you speed the machine up, just do a finishing cut and just get that where it's a little bit sloppy. Because right there, there's almost no movement whatsoever. So we make a quick belt adjustment here, and I will get the finishing cuts done. Alright, belts are adjusted. I'm just going to be doing a really, really light cut on each side. And we're going to go 2 thousandths on each side. pretty clean cut. Double check with the wrench. And it's got quite a bit more play, but I think I'm going to go a couple more thousandths just to give it a little bit more, because that is still not that much, and I think the paint will make that bind up just a hair. So I'm just taking it just about another thousandth, and that's it. One more cut on the other side. Leave it at the exact same settings, just feed in a little slower. This side cleaned up real nice, the other side's just a little bit rough still. And I don't like a little bit rough still. So feed in real slow, just try to get that cut looking a little bit cleaner. Both sides are really smooth now. Final check, and there's a lot more play in there, but like I said, when the paint goes on, that'll add just a couple thousandths, and that should take it to right where I need it. So next I'm going to turn it around and get it re-zeroed out, coming out the other way, and I have a jig that I use that I chuck up and I just thread it on. The only downside to doing it that way is all the cuts have to be one direction, but it allows for a little bit easier cutting because this is so short and there's not enough to really grab. All the cutting I do on the smaller end is with a 1/8 carbide end mill, and it cuts really easily through this steel, so I've never had a tool bit break or have had it wander too much or anything crazy. Alright, so I've got the little adapter that I machined up that this threads onto, locked it in, I've zeroed it out so that the wrench slots are straight up and down. This is going to be the sides of the muzzle device, and this will be the top. The reason I do it this way is that way I can put a parallel here. When I put it on the actual barrel, I level the barrel and then attach the brake and level the brake, so that it's indexed properly. This is all the same steel. I just machine a piece out that fits in, and I remake this every 10 breaks or so, just because I'm chucking it up and pulling it out over and over again. It kind of tends to wear the part a little bit. I've got my depth set. I've got the table zeroed out where I want it to index my slots along the edge of the muzzle device here. So normally I do this with the little flood coolant rig that I made up. I'm going to try it at least a couple cuts like this so I can show you guys what that looks like. With the flood stuff running, you really can't see anything. So I haven't cut like this in a long time. We'll see how it goes. The first cut. Lock this out, spin it around here. And grab my vacuum cleaner and vacuum that crap out of the way so you guys can actually see what it looks like. So it cuts a pretty decent slot through there. It's really small, but I don't want anything too gigantic. Looking at the depth of that cut, I need to adjust it just slightly. I'm going to go another 1/16 of an inch in and make another cut. This lock my position here. And that looks a lot better. And so it's kind of tedious doing this, especially on a manual machine like this, because it's a lot of work. But you get really nice finishes like this, and this is how I like to do it. Gives me something to occupy my time. I'm not going to go through and show all the cutting. I'm going to do all the cuts I need to do, then I'll come back if there's anything interesting to show you, and then I'll show you when it's all done. Alright, so I have the end plug seated in, a little chamfer cut into it. I'm going to TIG weld it in, so I'll go ahead and get started here. Now, I know it might look like I have quite a bit of stick out, but I'm using a gas lens, so it works pretty well for this. The only reason I got the gas lens is for doing these, because it's kind of small and tight space and it's easier to see it this way. that should leave plenty for me to machine off afterwards and still have enough weld metal there where it's not going to cause any issues. So that's the last fit up that I'm going to do, or welding that I'm going to do, and then I'll once it cools down, I'll throw it back in the lathe and clean it all up and do all the finishing work.